Hello, everyone, and welcome to this Introduction to Web of Things session. So together with Cristiano, we will explain what is Web of Things and what are the different standards involved. So let's start with a YouTube video. So this video is from a rather famous YouTuber, and it actually has a quite interesting title. As you can see, the title's view count, so the view count is closely synchronized with the title. And with so many views, it's very probable that it's not happening manually. And for most of us who are familiar with the web, the answer is very obvious. There is a script somewhere running that uses the YouTube API and basically looks at the view count and synchronizes the title with it. So if we think of the web, we also see this with mashups. So in the web, even though we don't use the word mashup that much, we very often see multiple services used together to create something bigger than the sum of its parts. So for a hotel booking website, we can overlay information from a map service provider together with a payment platform, and the weather information for the date you're booking can be also taken from another service, so that the hotel booking website doesn't have to do it all on its own. Similarly, for other places, we can overlay weather information or social media conversations and so on. So in the end, the APIs exist in the web for many years, but let's think how it looks like in the IoT space. They are also here, so it's no surprise. However, it's not so straightforward as you would have in the classic web. We don't have only HTTP, we have to welcome other protocols like CoAP, MQTT, and old ones like Modbus, or more automation-related protocols like OPC-UA, or more building management and automation protocols like BACnet. And this list will keep on growing, so it's just how it is. And it's also not about a web server sitting somewhere in a center. We have to really think of the individual devices and also their influence on the real world. And very often than not, it's domain specific, meaning that the way you interact with those things requires some sort of domain knowledge that is not simply abstracted. And another thing that we often see is that there is a dependency on the software development kits. So you have to use certain specific library, sometimes manufacturer specific, in your IoT devices. And in the end, there is a fragmentation problem. And this will not disappear overnight. We have to live with it. A lot of these devices, they are out there, and they need to be supported if we want to have a way to talk to all of them. And in a way, it is really like in the old days of the internet. We have basically multiple separate networks. There's no consensus on the protocols to use. And so the intuition of many of us is to say, okay, let's have one standard we agree on, and let's just change everything. But more often than not, what happens is that you will again have another competing standard with everything that is out there. So in the end, it's very difficult to mandate a single standard for all of the different domains. So we see it very clearly in the IoT space with standards like OCF from the Open Connectivity Foundation, OPC-UA for industrial automation, and there are other things like the AIoT in Europe, or the newly announced Matter protocol for smart home applications. So these different protocols and platforms and so on, they are already out there. And in the end, each domain has its own set of protocols, standards, tools, and vocabularies. So this is happening due to different architectures. So you could really think of like a case where you have CoAP, like here in a local network, and HTTP between the local network and the cloud, and or between the local network and clients out there. But very well, it could be something else where we see Modbus between devices and gRPC between the cloud and edge and WebSocket between the client and the cloud. And we can also have different types of security. So we could have a holistic, like system level security, most probably in like in a company network or a managed network where you can have one security mechanism or one basically firewall kind of for the whole system, or it can very well be that each device or each kind of local network has their own and the cloud and edge has their own, so you have to really live with this somehow. Yeah, and this is not a bad thing though. So these exist because there are different use cases and requirements, and we cannot mandate a single architecture to all for all devices to support. So let's go to the Web of Things, and with the initial idea for Web of Things, what we're seeing is from a book that is maybe 10 years old at this point, where at the time the authors have proposed to abstract the devices the way we talk with the REST APIs. So that you have a device that has resources like actuators, and each LED, for example, is under this resource. So it's like hierarchical, like a website, similar with sensors and so on. And this was the initial idea. And what we're looking at now with the standardization at the W3C is that this proposal is becoming something more, where it's about describing any kind of API for IoT devices using any protocol. It has basically now 4 normative deliverables, participants from over 35 organizations and dozens of implementations. Most are open source. And we are testing all of this in different events, what we call plug fests, and we really sit together and see whether all of our approaches really work and whether they are interoperable. We bring DIY devices to building automation controllers to connected vehicles, and we really test whether all of those promises work.
Okay, so now we're gonna go deeper into the standards. So let's start right now. Again, as Ege briefly introduced in the slides before, W3C is now standardized with Web of Things. So it's not just one single document, but it's a set of standards standardized by the working group. It's royalty-free and open. It's developer-friendly. We took kind of a next step to also understand the developers' needs and how we can improve their life. We have market adoption, as again briefly mentioned in the previous slides. It's open source. People can join us in the GitHub repositories that we will link later on, and you can basically see our steps towards the standardization. And basically, it's about defining reusable API description for everything. So, and one additional information I want to add here is that we are in the process to finalize that 1.1 version. So you're free to go and see what we published. So it's important to understand that the Web of Things is not a protocol. As said before, it's about describing different service IoT APIs using an information model that is standardized in the specification documents. So as you can see here in the slides, basically we are trying to cover the gap between the network protocols and the applications using a theme description. And in this theme description, you can find different building blocks. You have bindings, you have interaction affordances, you have semantics that you add on top of these building blocks to adapt the theme description to your application use cases. It's a narrow-waist model, and the end goal is to basically facilitate developers to create application that works across different protocols and IoT solutions, basically. So going deeper inside the theme description, here is basically the core of all the family of the Web of Things standards. And you can see it's composed by different components. Those 3 building blocks, properties, action, events, are called affordances. So it's the one that basically describe what the thing can do in the environment. In fact, they could even have effect in the real world, but they can also be associated with services. Here in the forms associated with the different properties and action events, we describe the protocols. So there you can say this is a property, and you can interact with an HTTP protocol or an MQTT protocol. And then, as I said before, you have semantic context. With semantic context, you are able to inject domain-specific information, the thing description, so you can adapt it in different scenarios. And on the right, you can see JSON-ready serialization. Right now, we support only JSON-ready serialization, but in principle, you can serialize it even with plain JSON. You have to respect this structure here, and you can use this document to discover and then use by your software agents. And so this is the document that is right now published. I guess we are closer to the 1.1 version, and you can go and read it through it. You will find all the information about what is the thing description, the use cases, how it's composed, and the definition of all the things that I briefly introduced to you. Now we will try to see an example of thing description, and here is a JSON-ready serialization as introduced. You have thing metadata. Again, this is important when you want to understand what is the thing about, and you have also human readable information so that you can specify the title and description. You have a unique ID that could be unique in your application use case. It does not need to be globally unique, like worldwide unique. It just needs to be unique for your specific application. You have security metadata. One other important thing that I missed to tell you before is that together with the forms, you are able also to explain security constraints. So what the clients need to do to access the resources is posed with a thing description. Again, semantic annotation. You see here we're using the add type to say that this thing is a sprinkle station. You can import different well-known ontologies in the thing description. You can define your own ontologies so that you can even interoperate with other solutions that understands the ontologies that you are importing. And here you have the core part, the affordances. As I said, these affordances are what the thing can do in the real world. And here, as an example, you see that you can start the sprinkle, you can read the temperature, because maybe this thing is a complex station as written here, and you have also temperature sensor, and you even know if there's too dry and there's maybe something that is wrong with it. And finally, you can create also a complex web structure of things, thing descriptions, thanks to the link field. Again, as usual in the web paradigm. So you can link other documents. You can, for example, here we are linking the documentation for these sprinkle stations. Going another level down inside the document itself, you see how the different affordances are described. Properties can have the title again. You can add also your own metadata here. It's completely open, but some of these terms are fixed by the specification, like the title, type, and unit. But you have also other elements. With the type, you basically describe the data schema of the property. And here we are saying that the temperature is a number and the unit of measure is Celsius. Of course, with units, you can even import terms from ontologies so that you are better interoperating with other clients. For actions, we have slightly different notation because action can have input and outputs. So here we are saying that this action has an input, an object, and is a complex object with properties, timeouts, and so on. And with events, we have the data field for explaining the type of the event. Here is just a string, probably saying it's true, dry. It depends on the implementation, of course. So now we are going to go deeper, one level down, and in the concrete protocol level of the thing description. Basically, now we are inside a property and the forms field of that property. And here you can see you have the protocol URI of the resource. So this is what identifies the resource in the Web of Things world. And in these places, you see additional information how the clients can interact with the remote thing, and obtain the information that they want. And we have a specific keyword to convey the operation that the client needs to do, which is this OP field. And for properties, we have read property and observe property. We also have write property and unobserved property. Here, the example show you how to read a property. And thanks to this protocol-specific vocabulary, the client can use the information to configure himself and then obtain the result he wanted. So for the read property, he needs to do a get operation at this URI, expecting the application JSON content type. Instead, for observing a property, it's more convenient to use MQTT in this fictional use case. So the theme description designer use MQTT, and he needs to describe to example light current daemon using a subscribe control packet, and the operation is of course observe property. So what you can do with a theme description? First of all, you can communicate with a thing. So you can read the whole document and then you can start interacting with it. You can do device processing and protocol translation, meaning you can read one thing description that maybe is written with just one single protocol, like for example HTTP, and then re-expose it back with another protocol. It could be MQTT or vice versa. You can use to generate UI. Once you know the data schema, you know what the content of the property is, or the action, the input of the action, or the output of the action, you can do UI generation. In fact, there are libraries that is able to take the JSON schema and generate the forms for you, for example. You can do device management. You can simply describe your devices with the thing description. You get the benefit to have a standard format that can be also used in other tools that are right now popping up in the open source landscape. But you can use it to collect and filter all your devices at your use case. You can do business logic applications, meaning that you can take different thing description, you can use them to describe software actors, and you can create complex application simply meshing up different thing description together. So that was the thing description, but this is not just one single specification as I introduced before. We have other satellite specifications. Starting from the architecture, there you can understand the whole concept of the Web of Things, and is a recommendation document. Then you have discovery, and with discovery, the goal is how to find thing description in the network, how to manage thing description, and how to interact with these particular services called thing description directories that expose a REST API so that you can filter thing description collections and you can retrieve different thing description from there. Then we have profile. Here is a wannabe recommendation document, and in basically there's a mechanism to creating a more constrained description, which is less flexible, but you are guaranteed to find some metadata and elements in it. And for example, you can constrain the way the protocol is described with easier implementability. Finally, as a non-rec document, we have binding templates. The binding templates are basically the place where the protocol information is defined. So we have seen the forms. You see that HTTP specific keywords or MQTT specific keywords, those keywords are defined inside the binding templates. And we basically have one binding template for protocol. Now that the specification is evolving and it's going to be able to describe even complex application frameworks or different data formats. Scripting API is again another non-standard document. It's just in W3C note. There you have the programming API for building consumer and exposure thing applications. Basically, it's a JavaScript API described in the document. It served as a way to basically help implementers to create libraries for thing descriptions and creating application thing description. It uses the concept from architecture to define, for example, what it means exposing a thing, meaning publish a thing description, what it means to consume a thing, meaning reading a thing description and interact with it. So there's finally also the use cases and requirements document, and This document is very important, even though it's not a recommendation document, because from there we take all the requirements that we are going to put back in the specification itself. So if you want to learn more, we have an official webpage also the W3C website. You can find the links below. We are also on Twitter. Please join us, follow us, and to get more news about what we are doing. Then you can try, you can get your hands dirty with our libraries that are published by third parties. So we have NodeWhat, which is an implementation of the scripting API, editor, which is a place where you can basically build your theme description, and the playground where you can validate and understand if your theme description is compliant with the specification. We also have tutorials. You can read the documentation that is on the website and watch some videos hosted there. Or we are hosting regular office hours week to week on Thursday. So you can join us wherever you like. You can find more in the calendar of the community group. If you want to stay in touch, we have other channels. We open a Discord server. You can join us there. We have GitHub issues or GitHub discussion where you can propose your ideas or basically give us an hand with the organization on what CG. You can even send an email. All the future events are written in our calendar, and if you want to check some TDs and examples, we have them hosted in what testing. So I guess that was all. Thank you for being with us today.